All right, today's lesson, we are still graphing absolute value functions. This is our day 2 of, there's 3 days, but this is our 3rd day. And today we are actually going to talk about what the graph looks like if you add or subtract a number after the absolute value. Yesterday we talked about what it was when it was inside the absolute value. So absolute value functions do have a general form that looks like this. This is what the general form is for an absolute value function. Now, I will tell you today, there will not be an A value. That's going to be Thursday's lesson. But today we are going to talk about what happens when we add or subtract inside the absolute value, which is what we talked about yesterday. And then today we are going to talk about what happens whenever a number is added after the absolute value. So whenever we had a number being added or subtracted around or inside the absolute value yesterday, that changed the center point. And it changed it to whatever value of x made that 0. So I don't know if you guys realized this yesterday. I do have some examples on the sticky notes towards the bottom of below the board from yesterday during 7th hour. But whenever you are adding or subtracting values, it actually changes the x coordinate by the opposite of whatever sign you see. So if you saw a x plus 3 in your equation, the center of the graph was actually at negative 3. If you saw an x minus 2, since that's minus 2 is a negative 2, the center moved to a positive 2, because the opposite is always what makes something equal to 0. So this is just a little review of what we did yesterday. This very first example is just like what we did yesterday. It's on Canvas on the home page. You might need to hit refresh. So this first equation is y equals the absolute value of x plus 4. So yesterday we made a table. Today we're not going to. I told you by the end of the week we would be doing this without tables. So if I look at this, do we see a positive 4 or a negative 4 in the equation? All right, we see a positive. Now, do you guys agree that the value of x that would make this 0 is negative 4, and that's what we would have made the center of our table? Negative 4 plus 4 is 0. So the center is always the opposite. So on this one, the center is negative 4 because that's what made it 0. So yesterday we would have made a table, and you would have told me, oh, I'm going to pick negative 4 because negative 4 plus 4 and take the absolute value, that's 0. And we would have made a point over here. Today, I'm actually okay with you just going straight to that without making the table. So on this one, that tells us that our x coordinate is negative 4. And that is the center, because that's the value that makes it 0. Now, did you guys notice yesterday all of the graphs looked very similar? Like you had a center point, and then whenever you made the table, negative 5 and negative 3, how far are they away from negative 4? They're just, did you guys notice yesterday that that's what your tables ended up looking like? So we would have a point here, and we'd have a point here, and we would make our graph. And the reason why we do this is because 5 is negative 5 and negative 3 are just 1 away. And so since we're talking about distance away from 0, at negative 4, that is the value that made it 0. And then the two numbers on each side of negative 4 are just 1 away. The negative 2 and negative 6 are 2 away, so that's why their y-coordinate is a 2. So I want to go back up to this general form for a second. When we look at this, inside of that absolute value, that's something that's being added to x. This affects the x-axis. Now, the second number that we call k is what affects the y-axis. If we add or subtract a number, it affects where that center point on the absolute value function is located. And do you guys agree that this point right here is the center of the graph? What's another term in math that we use for something that, like, where it makes a point or a corner? You know, say, help me out. If you've had geometry, it's not the origin. The origin is like 0, 0.
Vertex.
It's the vertex. So this point right here, and I want you guys to label that, that is called the vertex. It's the vertex because it's the point of the V. So in geometry, whenever you're looking at three-dimensional shapes and you have faces, edges, and vertices. Vertices is the plural for vertex. Vertices is always just points. So whenever we go to look at this, the equation actually tells you the vertex. The vertex of an absolute value is HK. So we've seen H's and K's a lot lately, haven't we? We saw them in circles. We didn't see them in ellipses, but now we're seeing them again in absolute values. All right, now I do have to ask you, in this general form, what kind of H is it in the general form, a negative or a positive? All right, it's a negative here, but what do you see over here? What do you see? Whenever I wrote vertex and then in parentheses, is it a positive H or a negative H over there? No, it should be a positive. So it switches signs just for the x-axis. So we switch the sign there. Now we don't switch the sign on the k value. So today, our center might move off of the x-axis if we're adding or subtracting something to it. So we are going to find the vertex today, and then from there, we'll say, okay, now they're 1 away, they're 2 away, and we'll make our points. So on that first example, I'm going to say, I'm going to erase this for just a second. All right, so the appropriate way that we would do this, I always just put V for vertex. All right, so in this, is this positive 4? Does that deal with H or K? And let me zoom in just a little bit on that.
H.
That's H. Now we see a positive 4 in the equation right here. Now we want to switch that sign. The vertex is a negative 4. Now, are we adding or subtracting anything after the absolute value? Is there a number? Are we adding or subtracting anything there? Nope. So that means our vertex is negative 4, 0. You can see, isn't that the coordinates of that point where we had the vertex? So your ultimate goal is to be able to look at an equation and you're going to be able to tell me the vertex without making a table. And then once we have our vertex, then it's a lot easier to make our graph. So if we take a look at the second example, I want to walk you guys through that because this one if you can see, we are subtracting something, but are we subtracting inside or outside of the absolute value? The outside. So when you are finding the vertex, the x coordinate is always dealing with what's inside the absolute value, and the y coordinate is what number is outside being added or subtracted. And those signs down there are the absolute value symbols. It's not an 11. So if we look at this first equation, are we adding or subtracting anything on the inside? Yes or no? Nope. Look inside the absolute value. Are we adding or subtracting anything there? All right, so if we're not adding anything, that's a 0, right? We're not adding a thing. Now we are subtracting a 2 after, so that's your y coordinate. We only switch signs on the x-axis, never on the y. So our vertex here is 0, -2. So we can graph our vertex. We don't go left and right at all, but we go down on the y-axis to -2. This is going to be our vertex. And then to finish our graph, we just go out 1 and up 1 each way. And then we do that again, out 1 and up 1. So today it's finding the vertex, and then we complete the V. And today all of our V's are going from the vertex are going to go up 1 and over 1 each way. So up 1 and over 1 once you have the vertex. I'll say, do you guys have any questions on that particular example? All right, now I'll say, let's skip down to number 3. Okay, we have 2 numbers on this one. All right, so just remember, for the vertex, we have 2 coordinates. The x-axis goes from inside the absolute value. The y comes from the outside of the absolute value. So which number are we looking at, the 3 or the 4? Which one deals with x?
3.
The 3. Now we see a -3 in the equation, so what will it be for the graph? A +3. So this deals with our x. This one here deals with our y. Now I'm adding 4.
Oh.
There we go. So our vertex is +3, +4. We only change the sign on the x coordinate. So we plot that point. Over 3, up 4. We've got our vertex. And then today, from our vertex, we just go up 1, over 1. Up 1, over 1. Now tomorrow we'll talk about different shapes on our absolute value, but this is what we're working with today. All right, now for the rest of these, I am going to need a little bit of participation. You guys are a little too quiet. You all right?
Yeah, I'm just tired.
All right, everybody tell me, which coordinate do you switch the sign on, x or y? All right, switch the sign on x, keep the sign on y. So let's take a look at number 4. All right, so for our vertex on number 4, what's my x coordinate going to be on my graph? All right, -2. We see a +2 in the equation. It becomes a -2 on our graph. Now what about the y coordinate?
-1.
-1. So there's our vertex. There's no calculations to it. You just look at it and tell me what it is. So then we can graph that point. -2, -1. We go to the left 2 and down 1. All right, then what do we do from here? Up 1 over 1 each way. And you can do this as many times if you have room, but 2 is honestly enough each way. But yes, you did do this in Algebra 1 last year.
This year kind of like a repeat of
This year you guys have done some stuff like your probability stuff and your quadratic stuff. We did a lot more this year than what you do, like baby steps in Algebra 1, but it's like in Algebra 2, you always take everything that you do in Algebra 1 like another step further. So like what we've done yesterday and today is the Algebra 1.
Yeah.
Thursday, we're adding one more step to it. And so, yeah. And that does kind of make sense that Algebra 1 and Algebra 2 would talk about the same things. It's just everything's kind of like a little step further.
And the good thing is you teach it from the beginning, so we ain't just like have to remember from last year.
Yes.
I mean, I get it now, but you wouldn't know.
Now, I will say this is the only year that I have spent as much time doing review but I also take the consideration that a lot of you did not have the last 9 weeks of Algebra 1.
Yeah.
So I can be a little bit more flexible. All right, any questions on number 4? All right, so now we're ready for the next page. All right, so number 5, I only see one number.
Then the y would be 0.
Okay, the y would be 0. So for the vertex, that 2 affects the x-axis. So is it a +2 or a -2 when I graph it? Yep, we always switch the sign for x. So if we see a +2 in the equation, we graph a negative. And then since there's nothing added, your y is 0. That's perfect. All right, so how do I graph -2, 0? Which way do I go? Do I go right 2, left 2, up 2, down 2? -2, 0. Left 2. There's our vertex, and then our other points, we just go up 1 and over 1 a couple of times. And that is it. I was like, can you guys try number 6? All right, so number 6, we've got it over here. I'm not going to zoom in too far because I don't want to lose. It'll cut off part of the graph. All right, and while you guys are working on number 6, I do just want to remind you, tomorrow is just a day to work on missing assignments. And so far, for first hour, there are 27 students, and only 14 of you have filled out the survey. So if you want assignments to unlock this evening while my daughters are at softball, I'm going to take my computer while they're at practice and get everybody's due dates adjusted on those, so that way it'll open back up for you at midnight.
Is the survey on Canvas?
Yep. And it's just you put your first and last name, what class period you are, and then there's a list of assignments. So like you might want to have your Harmony pulled up to see, and then you can check 2. Right, we're just doing a couple at a time, and then next week you have another chance to do more if you need to.
You can't hurt your score.
No, you can't hurt your score. It can only help. All right, what's my vertex for number 6?
1 negative 4.
1 negative 4. All right, so how do I graph 1 negative 4?
Go over to the right 1, and then you go down.
There we go. To the right 1, down 4. And then we just go up 1 over 1 each way for a couple of... Do you see how I always extend my lines across the graph? So I do want to let you guys know, I don't want to see stuff like this. No baby graphs. Extend your lines. So if you have not been extending your lines on your graph, make sure when you try 7 and 8, you do extend those. All right, so let's go ahead and attempt 7 and 8. Hey, do you guys want to go over 7 or 8 first?
8, 7, 8, 7.
I'll go over 8 first.
Yeah.
Your vertex on number 8 should be negative 4, 2. Do you guys agree or disagree with that? So negative 4 up 2, and then we just go up 1 over 1 from there and extend it as much as you can. How'd you guys do on that one? All right, on number 7. Your vertex is 0, negative 4. All right, 0, negative 4 is down here, correct? And then up 1 over 1. And there you have it. So tomorrow we are going to add, so if we wrote that general form and I said that there would be a number, we would wait until Thursday. So everything today was up 1 over 1 because that A value was 1. Like if you don't have a number, you can put a 1 in front of something, in front of X. So today everything had an A value of 1 and it went up 1 and over 1. Tomorrow we will have A values like of 2 where you go up 2 and over 1 each time. We might have values that are negatives where you go down. So tomorrow that A value is kind of like your slope. So we will add that tomorrow so you guys will see. We'll have some that are skinnier, some that are fatter, some that flip upside down. But that is the extension. That's the new part. That's technically the Algebra 2 part of this. And then we will do an in-class assignment on Friday